Hi, my name is Jonathan Dalling, and today we'll be looking at FRQ practice problem 3 for the AP Pre-Calculus exam. This FRQ is based on sinusoidal functions such as sine and cosine, given in a real-world context. So let's begin. A windmill on a farm rotates clockwise 120 times every minute. Point J is located on the end of one of the blades 50 feet away from the center of the windmill. The center of the windmill is located 320 feet from the ground. Point J first reaches its maximum height from the ground at t equals 6, where t represents time in seconds. As the windmill rotates, the height of point J above the ground periodically increases and decreases. The sinusoidal function h models the height of point J above the ground in feet as a function in time t in seconds. So right away, what I decided to do was know that we are given 120 times every minute is its rotations, and since the graph is based in seconds, I just converted that to seconds, which is going to be 2 rotations every second. And so with that knowledge, it will help us solve for question A, which states the graph of h in its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated. No axes are present. Determine possible coordinates T, H of T, and for the 5 points F, G, J, K, and P. So right away, we see that the graph of h shows us that F is equal to the maximum point right there. We know that the maximum point is going to be the distance from the ground to the center of the windmill plus the distance from the center of the windmill to point J, which is going to be equal to 320 plus 50. So we know that its height is going to be 370. We also know that F is the maximum, and it reaches its first maximum at time at t equals 6 seconds. So we therefore know that the t of f is 6. And with that knowledge, the next easiest one that I think to solve for is going to be point P, which is also the maximum value based on graph H. So since it's also the maximum value, it's going to have the same height as point F, which is going to be 370. And to find the x or the t coordinate, we're going to need to know the seconds. And since the windmill rotates 2 times every second, if it rotates once, it's going to be rotating once every half a second. So we know that the t coordinate for P is going to be the t coordinate of F plus 1/2, or 0.5, which is going to simply be 6.5. The next easiest one, in my opinion, to solve for is point J, which is the minimum value. So to get the minimum value, it's going to be the distance of the ground to the center of the windmill minus the distance from the center of the windmill to point J, as J is going to be pointing down. So therefore, that is going to be 320 minus 50, which is going to give us 270. To find the t coordinate, since we know f and p are 0.5 seconds away, we can take that value and divide by 2, as it's in between points f and p on the graph. So 0.5 divided by 2 is simply 0.25, and we add that to 6, since it's still between 6 and 6.5, which is going to be 6.25 seconds. Next, we can find the points G and K. Their heights are the same, as they're dealing in the midline. And so the midline is just going to be the distance from the ground to the center of the windmill, as in this case, we can see in the graph that point J is parallel to the ground at the beginning, and so we know that its height won't be up or down, rather it will just be perfectly parallel, and so then we can just know that the distance between point J and the ground is 320 feet. So we know that the midline is going to be 320. So that's going to be the h of t values for both points G and K. Now to find the t, we can do the same thing that we solved for for J, where it's between F and P. For G, we need to know the time between F and J, as G lies in between both those points. So J is 6.25 and F is 6, so the difference is going to be 0.25, and 0.25 divided by 2 is simply 0.125. And so since we're still within the 6-second range, it's going to be 6.125 seconds. Next, for K, we can do something similar, but this time is for points between J and P. Since J is 6.25 and P is 6.5, we know that the time is therefore going to be 6.375, and then the Y is already 320 because it's the midline. So for problem B, we know that the function h can be written in the form h of t equals a cosine of b t plus c plus d. Find the values of constants a, b, c, and d. So right away, we know that a is going to equal the amplitude of the graph, and the amplitude is going to be the distance between the maximum or minimum and the midline. And so since we know the midline equals 320 and the maximum is going to be 370, we can subtract those and get 50. So the amplitude, is going to equal 50. Now for B, the necessary equation to find this is going to be 2 pi over b equals the period. So we know that the period, or when the values become repeated, is going to be every half second. So it's going to be 2 pi over b equals 0.5. And so we can just switch b and 0.5, because if we multiply both sides by b, we will get 2 pi equals 0.5b, and then we're going to have to divide 0.5 to both sides to get b alone in order to solve for it. So it's going to be equal to b equals 2 pi over 0.5, which is equal to 4 pi. So we know that b is going to equal 4 pi. Now for C, C is the horizontal shift or horizontal translation of the graph. And so we know that in a cosine function, because it is a cosine function as informed, cosine functions have a starting point at their maximum value. And since the maximum value in this case is 370 at 6 seconds, we know that it was shifted over 6 seconds because that's when it first reaches its maximum point. So C is going to equal 6 seconds. And D is equal to the midline. And we know that the midline is going to be the distance between the maximum and the minimum. And based on our graph from part A, we know that the maximum is going to be 370 and the minimum is going to be 270. And so the difference between them is going to be 100, as that's going to be 370 minus 270. And so then we're going to want to divide that by 2, which equals 50, and then we can subtract or add the 50 to the maximum or minimum point respectively. So 370 minus 50 in this case is going to be 320 as the midline. Next, question C says, refer to the graph of h in part A. The t-coordinate j is t1 and the t-coordinate k is t2. So question C then says, refer to the graph of h in part A. The t-coordinate of j is t1 and the t-coordinate k is t2. On the interval t1 to t2, which of the following is true about h? So a few things here. So in this case, it's saying the interval from j to k is the interval of t1 to t2. So that's going to be this interval right there. So for the question, on I, it's asking on the interval t1 to t2, which of the following is true about h? So one quick tip is that it's talking about the graph of h, not to be confused with the rate of change. And so if we look on the graph of h, we can see that j and k, because these y values are positive, or the h to t values are positive, we know that the graph is immediately going to be a positive answer, so it can't be C or D. And then we have to look at if the graph on this interval is increasing or decreasing. And therefore, we see that this graph is concave up, which means that it is in fact increasing. So option A. And so when stating this value, I suggest you just say that the correct answer is option A, or you could say that h is positive increasing. You don't need to over explain it, or you could lose some points potentially if you say something incorrect. So next we have describe how the rate of change of h is changing on the interval from t1 to t2. So now it's talking about rate of change. And so when looking at this, we can clearly see that the graph is increasing, but what about the rate of change? So from the rate of change, we can tell based on the concavity of the graph, or in this case, the interval. So the concavity of the interval j to k is going to be concave up. And so we can say that because the graph is concave up, the rate of change over the interval of t1 to t2 is increasing. So one thing to note here is that you cannot get the answer correct or credit for the answer if you do not say this important phrase of because the graph is concave up. You must state that the graph is concave up in your answer, otherwise you will not receive credit. With that being said, that wraps up the AP Pre-Calculus FRQ3 practice problem. I hope you learned a lot, and I will see you again.